We're happy to have with us today Raymond Chandler from speakerbar.com, and he will be informing us on advanced and or lesser-known parts of Python, aspects of Python. So we've got, well, anyway, take it away.
Okay. Thanks. Like you said, I'm Raymond Chandler. I've recently founded a company called speakerbar.com. To fund that, I actually run a consultancy here in Columbus called AgileHog, LLC. Basically what we do is we help early stage companies define what their technical strategy is going to be, what kind of software stack they should use, open technologies, etc. Today I'm going to talk about super advanced Python. Before I do that, I'm going to talk about SpeakerBar. But I'm going to try to keep it brief because I'm giving a lightning talk on this too. So SpeakerBar is a website. It's an online community that ties speakers, event planners, and attendees together. As a speaker, you can upload all the information about your talks in one place. As an attendee, you can find information 3 months, 6 months, a year, 2 years down the line in one place, rather than having a big resource slide at the end of the presentations. Now you can just have speakerbar.com/your-profile/your talk, and people can go there and find information about your talk. The big impetus for this has been there's so much loss, right, between conferences and talk. There's so much loss of information. After you leave a conference, it can be difficult to look up that talk online. Sometimes the slides don't make sense. Sometimes you can't even find the slides. Sometimes you can't find, maybe you message the speaker on Twitter or something, say, hey, I was asking about this question. But it's really hard to get a discussion around the concepts you learned at a conference or a convention. So we're trying to solve that. We're very new. We just launched for this event. But stay tuned. Please sign up for an account. Follow me. Follow other speakers that have spoken at PyOhi. We hope to be in other big areas very soon. We're in talks with a lot of different conventions in the area. So let's get started. The first point of Python that you should at least come in here with understanding is that everything in Python is an object. Right? Everything in Python is an object. What is an integer? An object. Oh, by the way, while I'm speaking, I'm going to ask questions. I want you to shout out the answers. If you're wrong, I won't tell. That's okay. So the idea is to bring up some collaboration. So if an integer is an object, what's a string?
Object.
What's a class?
Object.
What's a metaclass?
Object.
What's a function? Everything's an object. Right? The second point, by the way, right here I'm working up a mathematical and logical proof that's going to like blow your minds, hopefully. Everything in Python can be grouped into a set, right? What's a set in when we think in mathematical terms? Does anybody know what a set is in mathematical terms? Very layman. It's a collection of unique elements, right? I like to think of sets as not being unique, but technically, in mathematics, it is a unique element, right? So we're going to talk a little bit about set theory. Set theory is a branch of mathematics that defines rules and operations for working with sets. What can you do with sets? Well, you can combine them together. You can split them up. You can do all kinds of really different things with them. Here are some basic concepts. You can union a set. When you union a set, you take two like elements. Here we have one list, and here we have another list. And I want to union the set using this OR operator, and I get a set of unique elements that have things that are either a member of A or a member of B. Right? You'll notice, like he said, unique elements, even though B is repeated twice in the set, it only shows up here once. Everyone good? Okay. Intersection of sets. Intersection between A and B returns only if a member is a member of both, right? So we have two lists, and here is the resulting set that is a member of both. Here's a set difference. If it's a member of A but not a member of B, this is a non-symmetrical operation. As you can see here, we get set A, and here we get D as an operation, depending on how we decide to difference the two sets. Here's a symmetric difference. It's denoted like this in mathematics. This is an XOR operation. Okay, so I have A, B, C, B, D, C. The set of A and B returns me A and D, because A is in this set, but it's not in this set, and D is in this set, but it's not in this set. Everyone following so far? Okay. Here's a Cartesian product. Anybody familiar with at least a little bit of linear algebra, understands what a dot product is and understands what a cross product is. So Cartesian product is a lot like a cross product. Here we have these two sets. We're just pairing AB, AD, AC, BB, BD, BC. This is how I can get a Cartesian product. Think of all Python collections as sets, during this talk at least. When I mention set, I mean list, right? As well as set. What is category theory? Category theory, actually let me go ahead and just ask the question. Does anybody here know what category theory is? Raise your hand. What is category theory?
It looks at essentially relations between functions as functions, and it's a substrate for group theory and other things, similar things.
That is exactly right. I want to focus on the idea that category theory is the study of change over collections of items, right? But it is a subset of, or a substrate moving into bigger things, right? So a morphism, does anybody know what a morphism is? It's a mapping. It's a mapping of a function or a functor to
Another one.
right. So we think in category theory, we think in functions, right? We think of functors operating over other functions, operating over some mutable or immutable type of data. This is the big language that everybody that has some knowledge of category or set theory knows that has, I don't know, inspired a language has probably been Haskell, right? Haskell is big functional language. Erlang, big functional language. All are heavily inspired by category theory. A morphism occurs when we apply a functor to a set or a function that transforms it into something else. I have a set of some data. I want to transform it into a set of another data, right? Critical point number 4 is for any set, we can apply some number of functors to arrive at any other set. Even if it's an infinite number of functors to arrive at some other set, there's some number of functors we can apply to some piece of data to make it transform into some other piece of data. The point of this is that anything in Python can be transformed into anything else by simply applying functors to sets. Right? Everything's an object. Sets are groups of objects. When we can apply any number of functors over a set to arrive at another set, so therefore we can apply anything in Python that can be transformed into anything else by applying it. Sorry, that actually doesn't make much sense. But read this, not what I'm saying. Graveyard, you'll see where that's going. So let's talk about list comprehensions. How many people here know what a list comprehension is? Raise your hands. Okay, so list comprehensions is sort of like an intermediate level idea in Python. What we do is we define a list, and then we define this weird looking syntax to transform that list into another list. What we're basically creating is an iterator here that's going to iterate over this list and return a new list for us. So here I'm just saying x times 2 for everything in the list, return me a result. You guys following? Here's a dictionary comprehension. Take a little bit, absorb it in. Anybody see two big differences in syntax here? So we have the curlies instead of the brackets. We also have this little notation here. What I'm doing is I'm saying this key for this value. So this is my value expression, this is my key expression. My key expression can also be anything. I could do k plus 1 or whatever and concatenate strings together there if I want to. For key value in my dict, does anybody notice anything here that's interesting right around this area? And actually, this is syntactically incorrect. This should be mydict.iteritems.
You get two values.
You get two values. I get a tuple, and I'm unpacking the tuple. Right? Tuple unpacking in Python is a really powerful thing. So if I have a long tuple of things, I can say this sort of syntax here to get back, extract the first item and then the second item in the tuple. I'm going to throw this away. I don't like it. I was trying something new. So here, all I'm doing is the same thing that you see in the list comprehension, but I'm maintaining the dictionary structure. Right? I'm just multiplying each value by 2, but I'm remapping it to the thing that was mapped to. Here's a bit more on a dictionary comprehension. Let me figure out what I'm doing here. Oh, I want to talk about iter keys, iter values, and iter items. So if I take a dictionary and I call iter keys, I get the keys. If I call iter values, I get the values. If I call iter items, I get the items in this list of tuples, which then I'm iterating over and I'm unpacking. We talk about lambda expressions. Does anybody know the difference between a bound and an unbound method in Python? It's part of an object specifically. Any object. So if a function is, thank you, by the way. If a function is mapped to an object, then it becomes bound. If it's not, it's unbound. How do you create unbound functions in Python? Lambda expressions, right? By the way, functions that you create within a class or within a module, doing def whatever specifically, binds that function to that module. So it's still a bound method. It's just bound to the module, not to an instance of the class. So here we're actually creating a lambda expression, which is an unbound method that takes something, multiplies it by 2, and returns you the result. So here I have a function that does the same thing. It's bound. This is going to be bound to my module. Here I apply the function for each item in the list using a list comprehension, and I get a result. But I can also do it here using a lambda expression. This other function, when I do this, actually binds other function to the module. But I can put this lambda expression, forget about other function, and just put it here. And then it becomes unbound. And then I can use it to pass every item in this list and give me something new. Lambda expressions are really powerful for doing very simple operations in Python. Enumerate. Enumerate is one of these rather unknown things about Python. A lot of people will use, in a for loop, will do for I in range of length of something. If you should instead use enumerate. Because enumerate will take a list of items. Here I see I zip, right? I'm using. Does anybody know what zip is? I actually talk about zip after enumerate. I should probably put it before. But I'm zipping each item, A1, B2, C3, D4. I'm just mapping them together, right? Enumerate does the same thing, but uses I think maybe it's an iterator. I don't know if it's an iterator or generator inside, but it will automatically enumerate your list for you into tuples. And then when you put it in a for loop, since they're tuples, you can unpack them, right? For this, to iterate over into an open for loop, I would do for I, letter in enumerate my list. Now I have an index for each of the items in my list. So that's enumerate. Zip. These are all, by the way, called Python built-ins. Enumerate and zip are built-ins. If you do a Google search for Python built-ins, you get a whole list of, I don't know, 30 or 40 different functions you can do. Did you have a question?
Do you have your slides online?
They'll be on speaker bar and on speaker deck. Yeah. So, I'm sorry, I meant to upload them. No, actually, they are in speaker deck. They are in speaker deck. They took forever to process, but if you do a search for me, my username is KITANATA. You should be able to download them. Or if you go to speaker, I don't think I put them on speaker bar yet. They will. They are on speaker bar. Okay.
Speaker bar, and then the talks link at the top, and then it's got all most of the talks from this conference, and Super Advanced Python is down near the bottom.
Okay. Awesome. Thank you. So zip. I already talked about zip a second ago, but it just pairs each item in two lists together. Can anybody tell me what would happen? What they think would happen? You don't have to be right about this. If one length is greater than the other, if I have one list longer than the other, what zip would do?
Cut off the extra.
Yeah. Zip truncates the extra thing. So if you have two lists, one's longer than the other. However, izip, which is an itertools library, will actually let you, there's something called izip longer, which will actually fill in nones for you in the shorter list. So it'll just pair none to whatever the other item is in the list. Here's a complex example of zip. I have two strings. Strings are iterables in Python. I can iterate over them like I would a list. So I'm zipping these two strings together, and I get this. And then I'm calling join on a string to combine them together, and I get a new result from it. It's an example of how to use zip. Here's another example. I'm just multiplying the key by 3, so I can get 3 exact copies of the same letter, and then putting it in a dict using a dict. This is a list comprehension. I'm unpacking. Cool. I'm unpacking the tuple that I get from zip using this, and then creating a dictionary from it. You can pass, one key thing here to take from this is you can pass a list to a dictionary, a list of tuples to a dictionary, and it will create a dictionary for you. Part of the expressiveness, the joy of Python. Things kind of just work together. Here is filter. Filter is the first of the 3 main functional functors that we can use over lists. What filter does is it goes through a list of items, and it does a truth test by passing it to each item in a list to a function that you provide, and that function is expected to return true or false. If it returns true, it keeps it in the return list. If it returns false, it rejects it. So here I'm asking if the number mod 2 is equal to 0. Is the number even? If it is, give me the number in the list. This is using not filter. This is using a list comprehension to do the same thing. And here is using filter. So first I apply a lambda. And then I pass in my list. And I tell it to filter it. An interesting thing, an aside, because this is one of the questions I said I would answer in this talk, is this is actually more performant than this. Can anybody care to take a guess why? Well, no, because Python internally actually creates an unbound method for this.
Is it more efficient to access that in memory because it's bound to something specific that it knows in its memory access? It's closer? More tightly bound?
Yes. Yes. It also actually, I forgot. Okay, so research for you guys. Any and all built-ins actually will look at a list, and if anything in the list returns true, then any returns true. So you can do this like, does all my usernames for everyone that uses my website start with the letter R? Right? What you would do first is you would map all the usernames using one of the next built-ins I'm going to show you, called map, and then you would go over it and look to see if any of those things result to true. So You need to transform some other set into something that can generate true and false statements for you. And then you just call any on it, and you can get something. And then you find out whether anything in that set is true. If all of them are true, it returns true. If any of them are false, it returns false. So that's any and all. Here's the map built in I was just talking about. What map does is it takes a function, a functor, and it applies it to each item in the list. By that I mean it looks at the first thing in the list, passes it to lambda, lambda returns a result, and I get the result. So this is the same thing as me doing this list comprehension. You'll notice also I'm starting to use other ways to generate my lists. Before they used to be explicit. If you want to generate a list of numbers, you should use range or xrange. If you're using Python 2.7, you should be using xrange. And Python 3, range is now a generator. And I'll talk a little bit later about the difference between iterators and generators and why you should use generators. What's up?
Do maps get converted to list comprehensions internally within Python? And if not, can they ever give different results for what look like equivalent ones?
First answer to the question is I don't know. The second answer to the question is I don't think so. So I have never encountered a situation where using a map goes through each item in sequence. So I don't see any way that it would be non-determinate, right? But I do not know if this gets translated to this. My first thought, and this would be another research thing, is these two things are slightly different from core in Python and how they work. Yeah?
Do you have to use these lambda functions for the map and the filter?
No, you can pass in any function to it. So if you have a really complicated function that's bound to a module, you can pass that. So I use lambdas because I want to understand that lambda is very basic and that it can do some basic operations for you. But yes, you can pass very complicated things to it. What's up?
So there's a relationship right between just writing a for loop, doing a list comprehension, and performing a map, right? You can do the same set of things with each of them.
Absolutely.
But in a for loop, if you wanted to have a side effect, like you had, say, a counter variable outside your loop, that's easy to write. You just do I plus equal 1 or whatever in your for loop and you keep going. In a map expression, it would be hard to do that side effect, which might be a good thing, but it's hard to do it. You'd have to explicitly introduce like a global or something like that to perform that side effect. What about in the list comprehension? Can you perform a side effect inside a list comprehension? Like, what's the scoping of the variables in the list comprehension?
Ask the second part of that question again. What's the variables in the list comprehension?
Yeah, what's the scoping of the variables? Like, can I perform side effects inside a list comprehension? No. Everything inside a list comprehension is scoped to that list comprehension. Okay, so it's more like a map than it is like a for loop.
Correct. Now, the interesting thing that you bring to the table is understanding like side effects of things that you're doing outside of the thing. Since writing a lot of my Python code in a functional style, I have found that to be a code smell. So if I'm doing something that requires a side effect, I am probably missing one of those functor to mappings that I was talking about earlier, where you have a series of functions that you're calling on a set that transforms the set into another set that you're calling again. So a good example of that would be something like if you have a set of strings and you want the string, if it starts with the letter R, to do something, right? I would actually first take and map the function to do whatever I'm trying to do, and then map the function on whether or not the first letter is an R, and then get a new set of that, and then reduce that down. And then I would have a number of things that started with R. Does that make... So that's an example of kind of... if you're programming with side effects, and you're trying to do functional style programming, you're probably doing something wrong. So that should just be I'm not dogging you personally. I'm just saying that's something to look out for when you start doing this.
The imperative versus functional thing is a whole conversation in and of itself.
Right, exactly.
I completely agree. If
Yeah.
you're attempting to do functional programming and
Right.
you have side effects, you're doing it wrong.
Right, yeah. What's up?
This is probably because I'm not as familiar with Python as I should be, but to make his thing concrete, suppose you change the times in that to times equals. Would either of those or both actually change my list?
If you did,
X times equals 2.
Like the original list. If that allows
I don't.
expression.
Yeah, I don't think that's allowing an expression to do times equal. And I think if it was allowed, because of the way that the function works, it's expected to return the result. So lambda has an implicit return in it, but whatever you return within your function would do something. But you cannot. So if we break that out,
Thinking of a quick way that might introduce a side effect.
Right.
This is probably a diversion, so feel free to ignore it.
no, definitely, it's a good question. I mean, this is meant to be a tutorial, so we can all learn, right? So I think that. If you were to expand that out into a function that was like bound to a module, so I had def do something, and then inside of that I pass x, and then I do x times 2. That x is only temporarily scoped, right? It's being passed in, and whatever you return, if you explicitly return whatever x was times 2, you're going to get x back, right?
That's sort of the thing, because in the math, I would expect x to be scoped to lambda, and therefore x star equals 2 to not affect the original list, while in the comprehension, I might think that x is actually aliased to the elements of my list, in which case x star equal 2 would affect the original my list, but I don't know enough to know if either of those are true.
In the case of list comprehensions, I know that it specifically prohibits that.
Okay.
So that's map built in. Is there any more questions? What's up?
But just, it's kind of related. So the lambda function, does that exist as a standalone, like a first class function? Could I then pass that lambda function into something else? So you do have that capability.
Mm-hmm.
I'm new to Python also.
Yeah. All functions in Python are first class.
Nice.
So you can pass lambdas to other lambdas. You can pass lambdas to other functions and just pass them around. When you do that, you bind them.
I was going to ask, so then another question that comes to mind. So in like JavaScript, so you've got like the concept of like closures, so you've got like memory access. Are you able to pass those?
I'm gonna answer that question later.
Okay.
Yeah. So we'll get there.
Okay.
But I appreciate your question. What's up?
For the recording, can you try to repeat some part of the question?
Sure. Absolutely. From here on out. Yep. Okay, so the reduce built in. Reduce, what it does is you pass it a function which takes 2 arguments. The first argument is the previous reduction of each element in reduce, and the second argument is the new element. So right here I create a lambda that takes 2 arguments, an x and a y. I add x and a y together. What happens is with reduce is in this list of things, I have a list of items from 1 to 6, right? Range goes up to, but not including the number that you pass here. So I have a range of 1 to 6. I am going to take the first item, which is 1. I'm going to take the second item, which is 2. I'm going to add them together. That's going to give me 3. That gets returned. Then 3 gets passed as x. 3 gets passed as y, because 3 is the next item in the list. We add those together. I get 6. 6 gets passed to x. Plus 4. That gives me 10. 10 gets passed to x. You guys understand the concept? I'm taking 2 things, and I'm collapsing it together. In Haskell, this is called fold. And I really like the fact that it's called fold L and fold R, which direction to fold an array. Because if you think of an array as a container of items, like here's 1, then here's 2, and here's 3, and you remember the old computer science, like when you took some sort of computer science, you'd have little boxes. I like to think of those boxes being like placed on a piece of paper and you're actually folding the boxes on top of each other. Well, what happens when you combine all those together, right? So I just a small interesting aside of what that does. So here is an imperative style, and here is the other style. And here is me doing the same list and getting a different result because I passed a different lambda, a different functor to it. The sum built in does the same thing as that first example for the reduce. So here I'm just adding two things together. Here I just call sum on it. Sum will automatically reduce all the elements in your list or set of objects. Interesting aside. Guido hates reduce. He's been trying to remove it from Python for a while. And I strongly disagree with his decision. Because in the case, his thought is that if you go, most of the time when you need to reduce something, you need to sum over it. So you should use sum, and I agree with that. But I have encountered very rare instances where I need to do a reduction on like a string and combine the strings together. Or I need to do more, well, I can't think of a specific example right now, which is not going to help me when this goes up on YouTube and they're going to go laugh. Like, Guido's totally right. There are instances I've encountered in my career where using a reduce operation would not have been possible with an existing Python built-in. But the vast majority of the time you're doing reduce, you should probably call sum instead. So, okay. So we talked about some basics of functional programming. Now we need to talk about what a closure is. So, I'm sorry, did you have a question?
I was just wondering, this might be part of Guido's hatred for it, but there's an easy way to do filter as a list comprehension, and there's obviously an easy way to do map as a list comprehension. There's no way to do reduce as a list comprehension, is there?
No.
You don't get a list at the end of it.
No.
Right?
Yeah. So that might have something to do with it, yeah. So, but, and for the record, okay, so what he said was that, that list comprehensions exist for, you can write filter and map operations as list comprehensions, but you can't for reduce operations. So that is possibly the source of Guido's distaste for using reduce. So that I think that is an interesting argument to make. So we're going to talk about closures. Does anybody know what a closure is? That can explain it succinctly, because the next slide I spent like 15 minutes just trying to come up with a decent explanation.
It's a function with some of its values bound from its environment.
That is a pretty good way of putting it. My explanation is a lot more complicated. So I said a closure is a function that wraps around some other function and some number of variables and closes over or traps it and contains it in its own scope, which is exactly what he said, but in a way over-engineered way. So I like your explanation way better. So let's write a very basic closure. Everybody's familiar with something like this, right? It's a basic function in Python that would be bound to my module. And I say I want to multiply x and y together, 3 and 5, give me the result, I get 15. Let's wrap it. So here I've created a function called mult closure, where I pass an x, but that inside of there has another function that gets passed y and returns x times y, and I actually am returning the wrap function for mult closure. So when I call mult closure and I pass in 5, this wrap function is going to close over 5 and get returned to me as if it was the original function. So what we say is that the inner function closes over this variable. Here's an example of the power of closures. I say I want a function that multiplies some number by another number, so I want to multiply 3. That gives me this function called multiply by 3. When I call multiply by 3 and I pass in 5, I get 3 times 5. When I call 10, I get 3 times 10. Right? It's a very, very basic idea of what a closure is. I'm closing over 3. Close over 3 and give me a function that multiplies by it. take a minute to just try to grasp what this is, because this is one of the hardest. This is like pointers, right? This is one of a fairly difficult concept to grasp in programming. Here's a, yes, what's up?
How would you document that?
Document what?
that example.
What do you mean?
What would the documentation look like? In other words, how do you...
Most closures are going to be hidden. So if you have an API, his question was, how do you document that? If you have an API, typically you're going to call something and you're not going to realize it's a closure that returns you a function that does something else. Sometimes you are. I don't know. I really don't. I'm sorry.
I have a suggestion.
What's up?
So for that specific example, you can think of the closure as a factory, right? You're probably using factory methods all the time. They return you objects that are parameterized in a certain way. This is a factory that returns you functions that are parameterized in a specific way. So it's just a function factory.
Okay, so to repeat what he said, which is genius, a closure is a function factory. And you can document it as a factory, as something that returns functions that help you out in some way. So everybody's familiar with factory methods. This is a way to do that. What's your name, by the way? Do you mind? Mike. Mike is the genius, and he's awesome. Buy Mike a beer, please.
No pressure.
Here is multiply by 10. I call mult closure again. Remember, I haven't defined a new closure, but I have, using the closure, used a factory to create a new function that multiplies some number by 10. Multiply by 10, 5. Pass in 5, I get 50. 15, I get 150. Okay. Let's go here. When should you use closures? Closures are great for drying up code. How many times have you written a function that's slightly different depending on like context? Right? You write really complicated closures that like will look at like the attributes you pass into like an outer function and like slightly modify the inner function to do something for you, right? When you need to write a complicated generator, closures are really good for creating generators in Python, which we will get to later. When you need to monkey patch a function, and when you need to dynamically build behavior by stacking functions together. Here's a monkey patch. There's this example here came from some library, right? Had really bad documentation, like two programmers that like live in their mom's basements who are like 15, right? Wrote this really cool API that looks really promising, but for some reason there's a divide by zero error in their library and I had to like search through and I need to override it because other parts of the library use that function or things that I need to call use that function. So if I call the library and pass in 10, I get divide by 0, and I get this nice little stack trace, right? Exception. Here's a closure that closes over the function. Right? So I close over bad function from the library. Bad function gets passed up here from the library. It gets closed over by this wrapped, which then, because bad function, this thing took an integer, right? It took some variable in it. So I pass to this function that attribute in here. But I catch the exception. And rather than printing a really ugly stack trace, I print the end of the world is coming. And then I return that function like a ninja. Don't panic. Catch it. I call catch it as 10. It's sort of my version of this function, and I get this wonderful, wonderful output because I'm catching it. You can use a closure to execute code before or after a function that you're trying to call. Right? This is an example of me monkey patching a function. Yes.
All right, so I'm still trying to wrap my head around this. So let me say what I kind of mean by close over.
Okay.
So by close over, you're kind of like saying you're creating a new function that retains some state from what you passed in and doesn't pay any attention to any changes to
what it is back there, back in some other space or whatnot, some other use. So it's like retain that, return, and cut the references to it, kind of.
So his question is, what really happens with when I say closing over? What is going on when we say closing over, right? So what's happening is this bad function, because it's being used here, gets scoped to this inner function, right? So it's got a reference to it, and it will always have a reference to it.
So it's retaining that as state.
Right, it's retaining the state of the original thing that's being passed in. Yes. So what's a decorator? Oh, yep, what's up?
This is intermission, so versus JS, closure in Python is read-only. Like, you can only read from those variables, you cannot change them.
That's correct. That's correct. I've actually ran into errors like that. So, but I didn't know you could modify the internal variables in a closure in JavaScript.
Oh yeah, that's part of the power of it.
Wow, that is awesome. I've been programming in JavaScript for like 2 years, and I did not know that, and I just learned something new.
It's like pointers with incredible benefits.
Wow, that's awesome. Yeah. Okay, so I'm going to start. Well, that makes sense, actually.
Why did they choose that?
Maybe safety. Yeah.
Sure.
So, actually, you know what? Now thinking about it, I have encountered that as a use, because I mean, yeah. If you think about whenever you make like a callback, you're basically creating closure, and then you're modifying the value of it, and then blah, blah, blah. So yeah, it makes sense. Yeah, that's awesome. So let's talk about what a decorator is. Has anybody ever used decorators? Anybody use @login required in Django? Right, like at something or another, right? Here's an example of a decorator. You guys see what I did there? Here's how I would use it. Decorators are closures, but not all closures are decorators. That makes sense. What a decorator is a closure that closes over a function, right? So in Python, it expects the function that you're closing over. I'm closing over this function inside of this don't panic decorator. I'm passing this to don't panic. It's the exact same thing as, must be on the next slide. Oh man, I got rid of that example. That sucks. All right, so what's happening here is it's as if I called don't panic on the slides. That's probably why I got rid of it, because it's like way back here. It's the exact same thing as doing this. If I put @catch it right here, forget about all that. I did @don't panic closure over top bad function from library, and this was a def right here, DEF, bad function from library or whatever, and this was my own function. I'm telling it to do this exact same thing. I'm saying create a closure, bind it to what my method's called, right? I'm not explaining this very well. So basically, it's syntactic sugar for closing over the function. Saying, take this decorator I wrote and pass the function that I'm declaring into the decorator whenever that function gets called.
And you assign it back to the original name.
And you assign it back to the original name. You can actually use decorators to monkey patch library functions that you should not be monkey patching in like weird ways. I won't go into that, but you can. So here's a logger. I am passing a function to a closure. That's the requirement to be a decorator. I am now also taking in all the arguments that would normally be passed to that function using *args and ** keyword args. I'm going to log the things that were passed to it, and I'm going to call the original function with the arguments that got passed to me, right? Because I'm basically like I'm a doppelganger, right? I'm like pushing the guy out of the way, and I'm saying, no, you sit there. I'll call you when I'm ready, right? And then I go, oh, I'm really that guy. You know, I hand you a fake ID and ask for alcohol. So here I'm saying log this function, logger, my function, return xy. So when I call this, my function 1015, my function is actually this logger because I've secretly doppelganged it, right? And I pass in 10 and 15 here to star args. It becomes a tuple, which then show up here as a tuple, which I'm printing. There's nothing gets past keyword arguments because I'm not using keyword equal whatever. And then I call the original function and it prints out because here I wanted to do this. And then I call print on what gets returned. Questions? No questions. What is the difference between an iterator and a generator? Can anybody tell me? Anyone?
Well, generator is going to create.
Generator is going to create.
And an iterator already has content now.
And an iterator already has a content. That is way better than my description. But that is an awesome, awesome description. A generator generates, and an iterator iterates, is what I was going to say. But like mine is like, okay, yeah, that makes sense. That's kind of part of the word where you're like, no, this actually is like a good example for you. So here's a basic generator. Looks like a function, acts like a function. Has this really weird statement here, yield, instead of return. Doesn't return anything, just yields. And then I pass a start and a step for it. What do you think this is going to do? Create a stepper, say stepper next. It starts at the very first start, right? 10, gives me back 10. And I say stepper next again. Next you can also call on iterators to iterate. So generator you call next to get the next value. Tells me 12. What's the next value after that? 14. Next value after that, 16. Yield is both an exit and entry point for the generator. And I put exit first for a reason. Because when we first call the step function, it enters here. And we set up, kind of like initializing in class, right? We set up some basic information. And I say, while true, infinitely run this, yield start. So I yield the first number it gets passed in. The next time I call next, it comes in where yield was. This now is the entry point for the function. I increase start by the step, plus 2, 10 plus 2 is 12. I go back up to the while statement, while true. Yeah, we're still true, we're always true. Yield start. Well, start's been increased by 2, so now we're 12. Do it again. I call, comes back in. So now it's exiting and entering from this place. But the very first time I call my generator to set up my generator, it enters here.
Are you using an internal closure or not at all?
This is not using a closure. Closure is specifically a function that wraps another function. Or do you...
Retaining an internal state too.
Oh, you mean internally in Python? Is it? I don't know enough about it. So, I think, maybe, I don't know. Sorry, I can't answer that question. I feel guilty, but I'm totally going to go learn. And then next time I give this talk, I will have all these answers. It's going to be awesome. What do you guys think will happen if I call list on stepper?
Run out of memory.
Don't do it, by the way. If you're like following along and entering stuff, please don't do this. If you do, hit Control-C really quick. Yes, it will run out of memory. A generator has no defined endpoint. It'll just keep calling it, unless you define an endpoint within the function. And we can fix it. So I say, well, I want to define an endpoint, end. So when I call this, I don't even need to pass end to it if I don't want to, as long as it ends. You might set this as max int if you want just to be safe. right? What's the maximum integer we can do? So you have some stopping point, and the future is just really big. So now I'm just saying when start is less than this end, then you can pass. So now I can call list on this. I can call list on this fine, and it will end when it ends. The while true is why it would run forever. So here I have stepper. I'm saying 10, 10. I want you to start at 10 and you to step 10 each time. Give me back a list, 10, 20, 30, 40. 40 is less than 50, but it doesn't hit the yield again. So here, step 5, give me 5 increments, and it's 60. By the way, we just implemented X range, right? Or actually, not exactly X range, but we're doing exactly what X range does. Here's a generator expression. This is something that not a lot of people use, not a lot of people know about. It came out in Python 2.5, and it's really, a lot of times when you're using a list expression, you should think about using a generator expression. So here, I'm calling list on the stepper. This is doing the exact same thing as my previous generator. This actually compiles internally in Python to the exact same thing as if I had written it out. Right? I don't have the while less than 50 here, but and actually this would, I need to do if x is less than 50, or else this function would run forever. So, which would be, no it won't, because it's iterating over this range. Sorry. So, what's interesting here, and something you should think about, is why am I calling list stepper? If anybody actually opened up a terminal and can type this in for me? You know what, let's do it. Oh, not that terminal. This terminal. Can anybody see that font? Is it too small? It's way too small. How do you set font? Anybody know? Oh, that's awesome. I love Mac. I'm still new to it, so I'm a Linux guy. Command
Enter, it'll make it full screen.
Oh, I love it. All right. If I print stepper, it's not a list. Stepper isn't a list, right? A list comprehension would return me a list. A generator comprehension returns me a generator. Why is this cool? And check this out. What happens if I do this? Does it start at the beginning? No. Because I've already stepped through it a few times using next. Here's the other really cool thing about generators. Each time I call stepper, I'm not creating a new list until I call list on stepper. I'm not taking up this huge place in memory, right? I'm only taking up enough memory to calculate what the next thing is. And it isn't until I call list on it do I take up memory. Why is this really cool? What happens when you're working with like terabytes and terabytes of data? Can you hold terabytes and terabytes of data in memory? No. But if I use a generator to generate through each of the things and step through each of the things, and then I can get really cool data back. Hey, check the time here. Okay, I'm good. We have a lot more to go. So, yes, what's up?
How the generators at the end, what does stepper.next return?
Ah, this is a very good question. Can anybody guess?
Stop iteration exception.
Stop iteration exception.
It's worth mentioning. Syntax, there's like an object-oriented class of style too. They work just the same.
Yep, absolutely. Yeah. You can program in a object-oriented style using classes and generators. And that was from Mike, the guy we're all buying beer for later. Thank you again. Let's see. Oh, there we go. I love it. Oh, look at this. I should totally do this from now on. All right. So generators. Look familiar. Looks like a list comprehension. Why should you use it? You're looking for large data sets. When I already went over that. I'm not going to do that again. Oh, when you're processing data in real time. Right? Generators are really good. This does not look good. I actually think that's like a picture from a Mushroomhead concert. And not necessarily zombies, but I like it. So, and I like Mushroomhead. So, the itertools library. Itertools is awesome, and not enough people use it. Chain takes two lists and combines them together. Two sets and combines them together. Don't think it can do it for dicts. Haven't used it for dictionaries. But what's the difference between doing this and doing plus? Chain is going to say, oh, I have these two lists. Well, I'm just going to, when I hit next, return the next item. Then I'm going to return the next item. Then I'm going to return the next item. Then I'm going to return 1, then 2, then 3, then 4. Right? I'm not returning a full list of things until I call list on it. So I can chain through, rather than creating a new list, say I have 20 lists, and each list is a gigabyte big, or even 20 megabytes big, rather than combining them all together and getting an 100 megabyte list, I only have the 100 megabytes from each separate list, and I can just go through the next one each time. Chain is awesome. Combinations. I love combinations, and the next function I'm going to show you is permutations after this, because I design board games, and I like to do numerical analysis on probabilities in my board games, and combinations helps that a lot. I can write Python scripts that will create combinations of cards, combinations of all kinds of dice rolls, combinations of things, and then run all sorts of calculations on them. Anybody know the difference between a combination and a permutation? And actually, there are two different kinds of combinations and two different kinds of permutations. I'm going to
cares order and permutation doesn't.
A what?
The permutation cares about order and a combination doesn't.
Correct. Yes. So that's the basic difference. But you also have, man, I can't think of the other one. I had it. I have it like. I'm going to learn from this and actually start putting notes in my talks, and rather than just showing examples and kind of winging it here. But yes, combinations will give you unique combinations of things between two sets of data, and it will do so through here. I'm passing a list. I have one list, A, B, and C. I want all the possible tuple combinations. So AB goes together, AC goes together, and BC goes together. Right? Here, I want a combination of, I have 5 elements in this array. I want combinations of all the 4 possibilities of them together. I don't care what order they're in. Permutations does the same thing, but cares about order. So if I call permutations the same way before, I get AB, AC. I also get BA and BC, because they're 2 unique different possibilities, depending on how they're ordered. And then doing permutations on this ended up being really long, but you get the point. And actually, just a thought, what happens if I increase this number to this list in length? Does it increase in length or decrease in length if I increase this number? Yes. It increases, does not increase the length of the list, but increases the number of items in each element. This is kind of a trick question. But compress. Compress is kind of like filter, except it's a generator. Actually, I think filter actually uses something similar to compress underneath the hood. But compress expects an array, which is a list, and another array or list of items that are true or false. The cool thing about this can actually be a function, right, that returns true or false. This can be whatever you want it to be. It can be whatever, as long as it somehow evaluates to true or false when either called or executed upon. I will go through it. It will work, and it's good. So here I say A, 1, A is true, A gets returned. 0, B, that's false. B doesn't show up. 1, C shows up. 1, D shows up. 0, E should not have showed up. F, 1, F shows up. So this is what happens when you type things out and only test about half the things you do. So this is equivalent to doing the same thing with zip, right? I'm zipping the two things together, and then I'm like checking the second item to see if it's true, right? I've actually written this code before I knew what itertools was. It's like filter things in weird ways. Compress allows you to apply selectors over a list and return things that evaluate to true within the selectors list. Count. Count does exactly what you think count would do. It's just like my original stepper, right? In the fact that it's also infinite. Count looks at the next item, just keeps returning 1 by the step that you pass in. Do not call length on count. Do not call list on count. Bad things happen. Cycle. Cycle is awesome. I love cycle. Cycle just continually returns the next thing in a list and then wraps back around. It's like a circular linked list, right? Just give me the next thing, give me the next thing. Oh, you're at the end? Okay, go ahead and give me the first thing. Give me the next thing, next thing, next thing, first thing, so forth, so on. I love Queen. Group by is like the coolest thing in itertools by far. And I'm going to spend a little bit of time on it because this is awesome. So group by expects a sorted list of items and then groups each of those items on a unique key value. By default, the key is itself. By that I mean it's an identity, right? So here I have a list of letters that have already been sorted. I have 5 A's, I think, 4 B's, 3 C's, and 2 D's. And I tell it to group by the list. And since the default key is identity, it gives me this as a result, which is also really interesting. Because if I just try to call print on the list, I get a dictionary, right? Or actually, I get a list of tuples that is, here's the key, and here's a grouper object, this is a generator, that's going to return the next things that are part of this group. What's the next thing that's part of this group? So this is actually going to return, each time I call next on this object, it's going to return A, then A, then A 5 times. Right? And it is going to return A 5 times. It does not consider this. This just becomes the key for those 5 A elements. What was your question?
Does group by itself return an iterator?
Group by itself returns a generator.
Right, sorry, yeah.
Yes.
Generator. Okay.
Yep. So that's why I call list on group by here. So if you want to extract out that data and actually get a more interesting thing, you need to do this. So after I've grouped my data, right, I want to put it in a dictionary. But group by is a generator of generators, right? Group by returns a generator of generators. So how do I, or a list of generators of generators. How do I get that? Well, I create a dictionary comprehension. I call group by, which gives me a generator, which also has a list of generators in it, right, for the second item in the tuple. And this should be group by.iteritems again. Sorry. Or actually, maybe it doesn't need to be. No, this actually does not need to be.
Change to Python 3, I think.
Yeah. So here I say, here's my key. Give me my key. Give me my list of items. Here's my list of items. And I get that printed out. And actually, this should be string, I think. I should be calling string on K. to get the string value for it. Try this. It probably does work like this, though. Here's a more complicated example of group by. Like, this is the power of group by, and this is why this is completely, unbelievably awesome. I have two IDs here that are the same. One has the name Raymond, one has the name Bob, right? And then I have this other ID. What happens if I group by, give this a key, which is a lambda function, I say just group on this element of ID, and this is also should be a right bracket. So part of the problem with this is I actually had a terminal open where I hand typed what my commands were in, and then like this is the right result given the thing. So so I pass a key here. It says I want the ID to be the key. Group this list. Give me key value pairs, and then print out the result. So I get for ID 1, I have this object. Then I have this object. They both have ID 1, so I've grouped them together. Here's ID 2. Here is a really super complicated example. This is an example of me applying several different functional style arguments, or this is functionally programming, and I'm trying to take this ungrouped list of items and group them together. Take a minute to take that in. So the first thing I do is I have a list comprehension, right? I say I want you to group on the key, give me 2 tuples back, and then for each of that tuple of things, I want to get the items. I want you to take the items of that tuple, and give me the value. And then I want you to reduce all the values together. All the result of this, reduce it together, sum it together. I could also call sum here. I actually probably should have called sum here. And then put that in a dictionary. And what that complicated code does is this. Using itertools library, I was able to turn this elegantly into this. So now name and email is mapped to the ID. An example, play around with it. It takes a little bit to get to understand how to program functionally. It is a huge hump. It's like going from iterative to object-oriented. Yeah?
To go back to your aside before, if reduce didn't exist, is Guido suggesting some way of doing this sort of thing without it?
I would call sum here instead, because this is summing 2 items together. But actually, the reason I did this and not sum is because these are strings, and if you call sum without an integer, it doesn't know how. Sum cannot sum strings together. So
what exactly are you summing there? Is it the 2 dictionaries?
Yes, I think. Probably, I wrote this a week ago, so that's the big downside to functional style programming. You have to look at it for a little bit to understand what the hell you were doing. Okay, so here is the dictionary of items. This is the grouper object. I'm passing the list of grouper objects, and then I'm just mapping to get the items out of that because it's going to return me a list. It's going to return me a dictionary because the list of items in that are dictionaries. So this is going to get me this first thing here in full, which is this value. Which is this list for this grouper item. I'm going to get the items, and then I'm going to concatenate all the items together. So name and email come together, and then then I create a new dictionary out of that. One of the things when you're doing this, when you're programming this there are advantages to this, even though it's difficult to read and it takes a little bit to wrap your mind around. It's determinant. Right? There are very little room for human error in here. Once I have a process that reduces sets and transforms them transforms them into other sets, it will always do that. There's very little room needing to test here, right? The other thing is this is nested. So I've made a really complicated thing here, and I've done it in this sort of style. But when you first start coming up with how are you going to program something functionally, and what functors do you need to apply to transform some data into other data, do it as single line items, right? First, I'm going to map it, and then I'm going to return that into a list. And I'm going to reduce that list. I'm going to return that into a single value, right, of things. And I unroll this into a for loop, right? And then slowly work it back into this form. The other thing to do is use Python interpreter. So I get this nice looking thing.
Quick question for you.
Yeah, what's up?
So, like, that's a good example to show some of the concepts you've been going over. If you cracked open some code and saw that, would you appreciate it or kind of scorn that person, curse their name?
I would appreciate it personally. That's me. I think most developers would. Most developers, I think, would scorn it. To be honest, in Python, we value code readability a lot. So the purpose of this is sort of as an example, right? I actually, if I'm using generators, I tend to do this. If I'm using iterators and I have limited sets of data, for the sake of code readability, I'm willing to give up a little bit more memory, and so I'll actually write them out line item by line item. It's a lot easier to decipher. And other times I just don't do it. So, but for this is doing a really complicated operation, transforming data. Most of the time when I use map, I use it once. It's by itself, and in that case, it's really good. So this is you're kind of programming in Lisp and Python here, right? So.
I was just also going to say I found that when I'm writing these really kind of dense, not one-liners, but things I'll change together, having somewhat more helpful names like X, Y, and Z really makes it a lot easier to follow where things are going. You can say, okay, this is the date.
Right. Yeah. So naming your things in not cryptic ways is probably a good thing too. So. No, is not probably, is a good thing. Please name your variables better than I do. Here's product. What product does is it creates a Cartesian product of two sets. We talked about it earlier, just pairs each item in two sets of data together. So here I'm going to create A1, B1, C1, A2, B2, C2, right? There's going to be what I get back, and I get a two-tuple of things back. And then here I am creating a dictionary comprehension that gets the first item and the second item and maps them together. iFilter, IMap, and iZip do the exact same things as map, but use generators instead of iterators. There's also iZip longer or longest, which is the one that gives you none back. And then there's another iFilter that I think rejects, iFilter false or something like that, which rejects rather than injects. If you haven't played this game, you should. We talk about metaprogramming. Does anybody know what metaprogramming means? Truly know what metaprogramming means? Yeah.
Writing things that generate programs internally rather than writing the programs themselves.
Writing things that generate programs internally rather than writing things themselves. Mm-hmm. Huh? Code that writes code. It's code that writes code. What is introspection?
Navel gazing.
Huh?
He said navel gazing.
Navel gazing?
It's code that can inspect itself.
It's inspecting code at runtime. It's code that inspects itself, right? Or knows what it does. Consider this. I have a swallow. It is not an African swallow. It has an airspeed and color. There's a basic class with an init function here. takes an airspeed, sets up the color, and now I have an unladen bird because it doesn't have an item in it. Let's talk about getAttr. getAttr is a Python built-in that you can pass the string of the method and get back its value. On this object, give me its airspeed. On this object, give me its color. On this object, give me its wingspan. It doesn't have a wingspan, so I get return none. Huh?
Can't that be done directly?
Yeah, it can be done directly, but you can't do this dynamic. You can't do it dynamically directly. Here, let's do this. So what happens when I have something that takes an argument and I want to get the right? So because this is a string and I'm not accessing it directly, I can change what that's going to be. hasAttr asks if the attribute exists on the object. Airspeed. Does the unladen bird have an airspeed? Yes, it does. Does it have a wingspan? Nope. Not on this object. setAttr is awesome. I tell it to get the attribute of the airspeed. I get the airspeed. I set the airspeed to 42. I get 42. Right? Next time I try to access it. I'm setting it dynamically. This class didn't have a wingspan argument before on it. Now it does. I just created a new argument here, and I pass 14 to it, and then I get the attribute back. Anybody have a question about this right here specifically? What's up?
When did it return false?
Question was, why did it return false when I set the attribute? What I'm testing here is whether or not that's a typo.
Maybe because the attribute didn't already exist, but I'm just guessing. Can people in back see the colors?
Oh. Yeah. Should it have changed?
Or a new tab.
Okay. Doesn't return anything.
Or maybe it returns its previous value, which would have been none in this case.
Yeah. We can't do it, right, to see what it actually gave back.
Mm-mm.
Wouldn't false come back as
Not, well, maybe. So print setAttr on my bird. Call it type. Actually, let's not call it type because it beak size 22 feet. Returns none.
Now try it again with wingspan.
Now, is that the only syntax? Like, I'm sorry, I'm coming from a JavaScript kind of perspective. Can you do the alternative notation with the square brackets? Or this is the way to do it?
This is the way and the only way to do it in Python. So back to my question. Anything? Pointer? There we go. Any questions about this right here? I can pass a function here and then bind it to this object. I can dynamically create functions for classes at runtime by passing it to setAttr. We're going to talk about type. You guys ever remember doing this? Calling type on something? What is the type of an unladen bird? It's an instance of an object. What is the type of int? Type int, right? What is the type of string? Type string. So go over here. Type on 35. Oops. 35 gives me type int. Type on ABC. Type string. Type on the list of ABC. Type list. I'm going to blow your minds. What happens if I call type on the class itself? I get a class object. But what happens if I call swallow._class? I get the class object. Right? It's two ways to get the same information. What happens if I print out the class object? I get class_main swallow because main swallow is bound to main and it tells me its memory address. What if I do unladen bird._class? Gives me the same information. There's nothing profound in that yet. What happens if I print the type of unladen bird.class? Remember, unladen bird.class give me the swallow. And then I say, what's the type of swallow? And it gives me a class object. What if I do this? What is the type of the unladen bird's class? Swallow. The type of that is a type class object. What is the class of that? Type. Type. The first thing I thought of when I saw this is like, oh, well, of course, because you're calling this type function, and you say, oh, that's actually a class because it's callable, and I get back class, and of course it's going to be type. Right? So what's the type of 35? Class. Right? And I call class on that type, and I get back type, because obviously I'm calling type. Right? Same here. ABC string, class. Right? What's the type of that? It's type. But it's because I'm calling type, right? No. It's not why. Here I don't even call type. 35, its class is an integer, type int. Its class is type. Type is the root class. Remember, everything is object? Type is Python's God object. It is the creation of everything good and evil, big and small. What do you think happens if I call some function, a lambda, maybe, bound, unbound, ._class, ._class? What do I get back? Type. Everything's an object because everything in Python is derived from type. Or built with type is a better way of saying it.
So when you're calling type on something, an instance or a class or whatever, are you calling a built-in on an argument of a particular thing, or are you creating an instance of your superclass type built out of the object you're starting with?
So the question was, when I call type on an object that exists, do I get back another object that is built with type, or is type just giving me a description of the object? Is that right? The answer to that question is it's at that point it's just giving you a description of the object, so that you can detect what type the object is. Type, like a lot of things in JavaScript, does two things. It acts as both a descriptor, gives you a description of an object. It also creates everything. Type's actual function signature looks like this. Takes a class name, or a class, or an object. It also takes a list of parents as a tuple. It also takes attributes that should be on that class. If this is none, or you didn't supply it, these are keyword arguments to type, and you didn't supply this, it gives you the description of what you passed in. But if you supply these things, it doesn't. Unless you pass a string here, in which case it creates an empty class object for you. Type creates everything. Here's how I can create that bird class like I did earlier. I call type. This is my class name, Untitled Swallow. I'm going to give it no parents. It's its own root object. I'm going to give it a default airspeed of 42 and a default wingspan of 15. Let me get a bird. I can instantiate this class. I get a new instance of it. What's the type of bird? It's type. Print the type of my bird. It's this unladen swallow. I've created a class using Python on the fly, using type. Print mybird.airspeed, get 42. Check if it has an attribute of wingspan. I get true. Question?
Your unladen swallow class is bound into main. Is it possible to bind it elsewhere? And if so, how would you do that?
It's bound to wherever you call type. Yeah. So I don't think there's any way to do it by calling type specifically and saying, even though I'm here, bind it to that module over there. You need to bind it within the module. So what is a metaclass? Anybody know, can guess what a metaclass in Python is?
It's an object of type class.
Okay, it is an object of type class. Here's a hint. Type as a metaclass.
It's a class that spits out classes.
Metaclasses are classes that spit out classes, and more specifically, a metaclass is any callable, a function or a class that implements type's function signature and then calls type. Here are a couple metaclasses. I take the class name, any parents it might have, any attributes I want in the class. I can do stuff based on that. Maybe I create a few other classes. Maybe I add attributes to the class on the fly. Right? And then I call type. Say, okay, now that I've done my stuff that I want to do, go ahead, Python, create my class for me, given some things. Maybe I add some things in class attributes. I create new attributes. Anybody familiar with Django's ORM or SQL Alchemy? The magic of Django, it's ORM, SQL Alchemy, Mongo Engine, any of those sorts of things where you can actually pass keyword arguments and they automatically get bound and it introspects the DB. It does all that with metaclasses by defining classes on the fly for you. Here's another metaclass using a class signature. This is a function, right? Metaclass. This is technically a metaclass in Python, even though it's a function. But here's a metaclass using a class. Since to make a class callable in Python, I override _new. So whenever new, unlike init, new describes how to create the object you're creating, and init tells Python how to instantiate and initialize the object. So here I'm saying, here's how I want you to create. When I call my metaclass in parens and I pass something to it, I'm passing it here. The first thing new gets, because it is a statically bound method, is the class itself, then the class name. Not, by the way, this is class, not self. This is this in Python, right? Because you have classes and you have instances of classes, and both are objects, and you can introspect both of them equally, right? I can actually redefine how a class init structure gets created on the fly, because it's an object, and it's bound to its module. And I can access it from the module, right? So here's class name, class parents, class attributes. I call type, and I call its underscore new. Because type really is kind of a class. Although I could do this here. This here is fine if I put this here. But I call underscore new. The reason I call double underscore new is because I'm being very explicit. And in Python, explicit is always better than implicit, right? It's one of our dogmas. So I'm explicitly saying, yeah, I'm overriding types new, and then I'm passing control to it. It's a lot more stuff. So here's what you can do in the do stuff part. You look at the attributes that gets passed in. You can set new attributes. You can create new classes on the fly. Instantiate all kinds of stuff. Create functions. Traverse the parent classes. Remember, the second argument here is a tuple of classes. Like, this is my immediate parent, and this is who their parent is, and this is who their parent is. I can look at each of the parents. Maybe their attributes have changed over time. Maybe I want to detect that. Maybe I want to see 3 derivations up, 3 ancestors up, and look to see if it has an attribute on it, right? Specifically that class, not my derived class. I can do that. And change values in the class. Type creates the class, not the instance. This is like completely important here. Type does not instantiate classes. It creates a class object that you can use to instantiate classes. Right? It's the same thing doing class bird here. It's the same thing as me doing right?
I always think of it as it creates cookie cutters, not cookies.
Right. It creates cookie cutters, not cookies. That's awesome. Awesome example. So what does this do? Remember, my meta class is, where's it at? There. That's my meta class. Immediately obvious answer is it actually does nothing, because that comment of do stuff there doesn't really do anything, right? It just calls type. But I'm more talking about what does this part of it do. It's defining what meta class to call to create the object. Yep.
So that's
absolutely.
Double under meta class?
Yes. Yep. Double under meta class is so what happens is Python says first looks in a class that you define. It says, hey, does this have a meta class attribute on it? Right? And if it does, then it uses that meta class to create the object. If it doesn't, then it says, hey, does this class have any parents? Does zombie killer derive from anybody? If yes, then let me look at their description and see if they have a double underscore meta class parameter. Do they? Yes. Use their meta class. No. Go up. Keep going up. Turtles all the way up until we get to the root object.
So if you do both, will it just ignore one of them then?
It will ignore one of them. It will use the derived meta class. If no meta classes are defined, it uses the default meta class, which in Python is type, to create the object. What's up?
Is that the same? Is writing that the same as writing zombie killer equal my meta class open parens and then pass the arguments as you go back to type?
Absolutely. Okay. So the question is this equal to me doing this, which is, this is not going to work because I don't have anything scoped, but right? If I implemented what my meta class was, I would get, right? This slide here is the same as this code down here. So this is syntactic sugar for this. Oops. Here's some rules about using metaclasses in Python. These are guidelines, I guess. They're not strict. Don't ever use them. Right? Don't ever use metaclasses unless you're writing SQL Alchemy or Django's ORM. Right? Usually, you can do what you need to do using type. If you must call type, you should probably avoid calling type too to create classes. Or you can use getattr, setattr on the fly. If you are building a complicated and highly dynamic API, the metaclasses are your thing. And you should totally use metaclasses. 90% of the time, you don't need them. Make your metaclass a class, not a function. You'll notice over here, when I created my metaclass, you see what it derives from? Type. So I, as a programmer, when I look at this, I don't immediately recognize that these 3 arguments makes a metaclass. Right? Sure, it's doing exactly what type does, and it's calling type, but that may not be immediately obvious to me. But when I'm looking at your class and I see that it derives from type, that's an immediate red flag to me that tells me this is a metaclass. This is deriving from type. This is doing exactly what type does. What is type? A metaclass. So if I derive from type, logically I'm a metaclass as well. Please write metaclasses this way. Avoid this, please. As an aside, just to kind of drive the point home, I hate class-based views in Django. So if you use Django and you use class-based views, I hate them. I hate generic views. I don't write them. I always write them as this. But when I write metaclasses, I always write them as this. So please write them in like that. Make your metaclass a class, not a function, and derive it from type. So that's it. If anybody's played this game, these things are scary. I have a really hard time killing them. I have to use a shiv, and then my shiv breaks, and then 3 other clickers come out of nowhere, and they're like, yeah, I'm dead. You guys have any final questions? How do we do on time? Wait, oh my God, I'm way short. Do you want me to go back to any examples? Have a discussion around an example. Can I do a quick survey? How many people learn something new? How many people's brains hurt right now? Okay. How many people think I could have explained things better?
You did good. Yeah.
Okay.
Kind of heavy at some points for movies, so.
Absolutely. So please take what you've learned, apply it, and find me on SpeakerBar, comment on my talk, give me feedback, rate me. Rate me. Sign up for SpeakerBar as an attendee or a speaker if you speak. Show that you've attended my talk, and then hit the little gavel icon to judge me. I need being judged. Thank you guys very much. What's up?
Do you have any recipes that you've made?
Oh, this is an excellent question. So the question is, are there any recipes for combining things together? On the itertools documentation page and Python core docs, there are recipes for here's how you do this, here's how you do this. And actually, that would be a great concept for a book. Here's how you do functional programming in Python, and here's how you combine these things together to do these sorts of things. Just to give good ideas.
We spent a lot of time asking Raymond how he implemented working. Raymond Herzig.
For what?